Cool, awesome. So welcome to Financial Maths. We're going to just go very broadly into everything. So here's the plan of action today. So we're just going to look at a brief introduction and then of course all the financial maths topics, simple interest, compound interest, decay, growth periods, and nominal and effective interest rate. So it's going to be a lot of fun. If you do have questions, you can pop them up into the Q&A or into the chat. Either is awesome. And then, of course, I'll briefly explain what Future Fund 2.0 is and any additional resources that you might need. So, firstly, financial maths is one of the most important and most relevant maths applications that we're going to have while we do grade 10 to 12 maths. I mean, if you get a question, where do we use this in real life, then I don't know. This is one of the things that it's pretty obvious for. And there's so many nice applications that you can use for both simple and compound interest. I was actually thinking about it this morning. I mean, simple interest is basically a straight line. So your I would be your gradient, and your P times your gradient would be your starting point. So it's such a fascinating, in fact, no, your P would just be your starting point. So that's really quite an interesting thing to look at if you're looking at graphs in general. And then of course, I did a BSc and studied genetics. So we looked at population growth in bacteria and in fact used the compound interest formula to calculate bacterial growth. So we'll do a question like that just now. And then of course you can use it to predict your sales, the value of an item, the value of your car in 10 years time. So lots of great, really useful applications in the real world today. Cool, so the calculator I'm going to use today, of course it's sponsored by Sharp, so I have to chuck this in here, is the 535. It's got 422 functions. It is approved by the Department of Education. It has an unlimited table mode, which we're going to use a lot today for simple and compound interest. And then, of course, some other great new features: highest common factor, lowest common multiple, easy to use statistics, which I'll show you on when we're doing stats, Tuesday or Thursday night, one of the two. So lots of fun stuff. All right, so let's jump right in. So simple interest, your formula is A is equal to your principal amount, 1 plus IN, so a PIN. That's the way I normally remember it. So your P is what you put in originally. It's how much you want to invest at the starting point of your investment. Your A is the final amount that you receive. So it's what you're getting out after however long you leave your money in that investment account for. Your interest is the rate. So it's the percentage that the bank or whoever is willing to pay you to borrow or keep your money safe. And then of course the period is the amount of time you invest in years and months, etc., etc. Okay. So let's start with a very basic example. What I want to do is actually do this on the calculator with you, because this is such a nice topic for playing around on. So I'm going to go to my calculator and I'm going to press mode and 2 for table. And then we're just going to do basic simple interest functions. I'm going to say I have 1,000 Rand and I'm going to invest it at 10% interest per year. And I'm going to actually just multiply it by X for my number of years. Okay, and this is really nice to explore. So here we can go, I'm going to leave function 2 for now. And here we can go through them. So it's really nice to see, if you look at, after 1 year, you have 1,100 Rand. After 2 years, you have 1,200 Rand. After 3 years, you have 1,300 Rand. So you can see, it's quite obvious that your money is growing by 100 Rand every year. Okay, and so you can see with simple interest that the interest amount that you get paid out never changes. So when will your money double? It will double after 10 years at a 10% interest rate. Okay, so that's a really nice way to look at your simple interest. Okay, so it's all here for you to see and all the steps on the calculator. It's a really nice way to get your kids to explore simple interest. So let's do some example questions. The first one, it's all written. Okay, so determine the missing values. So Joe invests 500 Rand for 3 years at 8% interest per year. So we can look here. So we're looking for our A. We want to know what he's going to get out after 3 years. He invests 500 Rand. Oh, sorry, guys. At 8%. And it's over 3 years. So we know our formula is the simple interest formula. And then all we have to do is put in the values for each of those individual items. So P is 500. Your 8 is, or 8%, remember, is as a percentage is written as a whole number, but it can be written either as a fraction, so 8 over 100, or it can be written as 0.8. I like to write it as 8 over 100 because later when we do compounding intervals, it becomes quite handy to have that fraction already. Okay, and then of course 3 years. Sorry guys. I'm staying over at a place with cats and I'm allergic, so it's really great. Anyway, so do I need to do this on the calculator with you? So basically, let's just do it because it's fun. So from here, I'm just going to press the home button and home will just take me back to my normal mode. So it's really nice. It just shortcuts the mode 0 for normal sort of thing. Okay. So we have 500 Rand and open brackets 1 plus, it was 8%, eh? 8 over 100 times 3 years. And that's it. So very simple, very easy to do. Okay. Cool. So if we look at the next example, Aubrey receives 1,400 Rand after investing for 5 years at 21% interest per year. So where can we fill in these values? Well, our A is going to be the 1,400 Rand. N is the 5 years and the 21% will go in our interest. So we're looking for our P value. So our formula is again the same. It's simple interest. And so we can substitute in for our A, and we don't know what P is, so that's what we're looking for, and our interest rates and our number of years. Okay, so of course, we need to solve for P, so we make P the subject of the formula by dividing by this entire bracket on both sides, and that's what's happened over here. Okay. And then, of course, we can type that all into the calculator. So I'm going to do that now. Sorry, I've pressed the wrong thing here. And here's my calculator. So we've got 1,400 over, and then we're going to open brackets. 1 plus, it was 21%, right? Yes. Okay. So 21% over 100. And it was for 5 years. And we want to know what he originally put in. Oh, sorry, I need to put my bracket here and not at the top. And equals. And so he initially invested 682 Rand and 93 cents. So obviously, if you're working with simple interest or compound interest, these values are always going to have your commas at the end. So you just need to remember to round off correctly. Remember, anything from 5 and up is going to make the next number jump up. Anything less than 5, so 4, 3, 2, or 0, is going to keep the number the same. And that's a very important skill to have forever and ever. So there you go. Alrighty, so that's it. So part of simple interest is hire purchase. So that's when you buy something that's really expensive, like a car, for example, although hire purchase you wouldn't buy a car with, but like furniture or a phone, something that's expensive, but not hugely expensive. So with hire purchase, they tend to also use a high interest rate because it is simple interest. Whereas if you're buying a car, they give you a lower interest rate, but it's compounded. So effectively, it works out almost to be quite similar, depending on the rate of interest that you pay and how long you pay for something. Okay, so the first thing that you need to do with the hire purchase is to work out how much your deposit is. So that they'll tell you, okay, your deposit is 15%. So I'll go through example after this, but you do need to know how to calculate a percentage, and I'll show you a shortcut for that as well. Then you need to work out how much you have left to pay, and that's simply taking the total value of the item or the total price of the item and subtracting your deposit. Okay, then you need to work out how much it would have cost you over 3 years when you have multiplied it with your simple interest. So what the final amount that you have to pay is once you've added the simple interest to it. And then, of course, divide this amount by the number of months that you have to pay. So if you're given 2 years to pay something off, you would divide it by 24, which is 2 years times 12 months is 24 months. If it was weekly, which is unusual, but can happen, there's also just something to think about for another question, you know, change the game a little bit. Okay, so here's an example. Mandisa decides to purchase a lounge suite from House and Home. Here is a picture of the advert. So basically, she's going to buy something for 14,999 Rand. Okay, and then here are all the questions which you will see I've copied across to each side, so don't panic about those. Okay, so if Mandisa pays a 15% deposit, how much will she have to take out a hire purchase loan for? So her initial amount is 14,999, and she needs to calculate a deposit of 15%. So here, I'm not going to do it on the calculator because you can see quite clearly the steps here, but all you would do is type in that amount times 15, and then to do a percentage calculation, you just press second function and 1. Now here, remember, you don't need to press your equal, and let me just do it because, you know, sometimes demonstration is better. So we have 14,999, and we want 15%, so we're going to say 15, second function and 1. And there is my deposit that she has to pay. So she's got to pay 2,249 Rand and 85 cents as a deposit. Now we need to work out how much she has left to pay. So we can also say 14,999 minus 2,249 Rand and 85 cents. I hope I got that right. And so that's how much left she has to take a loan out for. Now there is a really nice shortcut for this, okay? So what you can do, if they're not asking you for the actual amount that is deposited, but just for the final amount that she has to take a loan out for, you can also just say 14,999 minus 15%, and the calculator will automatically calculate that for you. So it's a really nice shortcut for those kinds of questions, and particularly for the Math Lit guys as well. Okay, awesome. So there's the shortcut, just so you've got it. If you would like these notes, I'll send them on Monday, along with a link to the recording as well. Okay, so House and Home charges her 22% interest per year, with the loan payable over 3 years. What is the total amount Mandisa will have to pay back? So this is your actual simple interest calculation here. We're looking for your A. We know we have to pay back the remainder of the amount, which is 12,749 Rand and 15 cents. The interest rate is 22%, and it's over 3 years. Okay, so there's my formula, and then I substitute each of my values into it. Okay, and then again, it's as simple as typing it into the calculator. So here, because I've got this as a last answer, I'm actually going to use the answer function on my calculator, just to save me time typing in stuff. And then it is 1 plus 22%, so over 100, and it was over 3 years, so times 3, and we can say equals. So her total final amount is actually going to be 21,163 Rand and 59 cents. Remember to round off. Okay. So from there, it's asked if she also pays a monthly insurance fee of 29 Rand and an admin fee of 13 Rand, how much will she have to pay a month? Okay, so firstly, how many months does Mandisa have to pay off the lounge suite? That's 3 times 12, which is 36. This is just times tables. You should know them off by heart. So use your drill mode and practice. Okay, and then of course, if we divide this answer by 36, we'll get to 587 Rand. So again, on your calculator, because you have your last answer here, we can just say divide by 36. Now remember, when you're working with a calculator, it becomes much more accurate. So for your answers, you might write 587,88, but when you're doing your calculations for your other stuff, then you can just leave the full decimal places in place until the very end to give you more accuracy. Okay. So that's that one. And then, of course, we just add all of those things to our total. So we're going to have 13 Rand and 29 Rand and 587 Rand. And our total then becomes 629 Rand and 88 cents. So that's how much it's going to cost her over 36 months. Okay. Now, of course, you're wondering, is it really worth it to do it as hire purchase? So let's say she wants to know how much more is she spending because of hire purchase, rather than just paying it out in cash. Okay, so over 36 months, she pays 629 Rand and 88 cents. And so we just multiply that, oh, sorry guys, we just multiply that across by 36. So she pays a total of 22,000 Rand, almost 23,000 Rand for a couch set. And so if we subtract, so she pays that over the 3 years. She pays the deposit. So don't forget to include your deposit in this question, and then subtract the original amount. She pays nearly 10,000 Rand more for the couch because of the simple interest. And that is basically just paying the bank. So be aware of that if you're looking at buying anything with simple interest or hire purchase. Same thing. Okay, so the next thing then is to look at compound interest. Now, compound interest differs if you just look, the definitions are exactly the same, but your formula is different. So instead of having your n flat on the ground, your n is now an exponent, okay? And that changes things a lot for you. So I'm gonna go back to my calculator now, okay? And I'm gonna go back to table mode, and I'm gonna put in, just for comparison purposes, here is my simple interest formula, right? And times by x. And then for my second function, I'm going to put in my compound interest formula. So I'm going to use exactly the same values, because it's nice to actually see exactly what's happening. All right. And then to the power of x. To make an x here, in case you haven't seen this, you just press your RCL button twice, okay? And then equals, leave our start and step as 0 and 1. It's not necessary to change them. Now you'll see after 1 year, your values are exactly the same. And that is because you are adding your original amount in interest to your first year's savings, okay? But here, the second year, you can see that the compound interest has grown by an extra 10 Rand, whereas the simple interest hasn't, okay? And if I look at year 3, now I've got an extra 31 Rand, and year 4, I've got, and you see that your things that you're adding every year are different. So it's not 100 Rand all the time. What you're adding is 10% of your previous year's interest, okay? So that's the difference between simple and compound interest. Now, what's really nice here is you can ask, okay, so when does your simple interest value double versus when does your compound interest value double? So ironically, we're actually on the answer. So here's compound interest, it doubled at 8 years, and at 10 years, that's when your simple interest doubled. Do you see here, it's almost 25% higher than your simple interest stuff. So if you're going to invest in anything, it's a very good idea to invest in compound interest if you are looking at a long-term investment. If you are looking at a short-term investment and you have a higher simple interest rate, then simple interest is definitely the way to go. But that's something that you need to work on, and you use these skills to calculate yourself as well. Okay. So some other nice things we can ask, when does your compound interest value double your simple interest value? So we can just scroll through the table, and we're looking for when this one is twice as much as that one. So let's see, no, yeah, that's it. So at 19 years, you have 6,000 Rand from compound interest, whereas at 19 years, simple interest, you only have 2,900 Rand. So you can see the dramatic difference in growth between compound and simple interest. Cool. Any questions so far? We're all good. We're still alive. We're drinking our coffee. I'm gonna have a sip. Awesome. Okay. If you do have a question and you're worried about typing it quickly, just wave at me and then I'll wait for you to type it in. Hi, Sianda. Are you just saying hello or do you have an actual question? I'll give it a pause. Okay, so here is your compound interest. I just did it as an individual graph on this example, but it was really nice to see and compare across the two of them. Okay, so let's do an example on compound interest. So obviously I've put these questions again into the next one. So Linda put 6,000 Rand into her savings account, earning 5.4% interest per year for 3 years. Okay, so what do we have? That's our initial investment, the 6,000 Rand, so that's our P. Our interest normally is a percentage, so that's quite a giveaway. And then of course 3 years is your N value. Okay, so we can substitute that into our formula. And then of course, it's as simple as typing it into the calculator. So here we can do it. So let's go back home. So we have 6,000 Rand, open brackets, 1 plus, it was 5.4%, right? Over 100. And then close your brackets to the power of, and we're going to put in an X instead. And here we go. So equals, so, oh, sorry, my bad. I shouldn't have put in X. I should have put in 3 years. I was wondering why that value was so high. Okay, so there you go. So after 3 years, her interest, her investment has grown by 1,000 Rand. That's not bad. That's a decent investment. It's a small interest rate, so obviously, but we'll look just now at how we can increase these things as well. I see there is a question. Cecilia, I'm not going to do future annuities today, but if that is something that you would like, I will schedule a workshop for you. Okay. Alrighty. So from here, we can look at your second example. So Lenka wants to earn 1,000 Rand in 5 years' time, and using 13% interest. How much should he invest? Sorry, I see there's another question. No worries, Yanda. Okay. Okay, so we want 1,000 Rand in 5 years' time. In other words, our final amount must be 1,000 Rand. Okay, and then of course our interest rate is 13% and our N is 5 years. So there's our formula, we substitute it in, and now we're looking at P. Just as a side tangent, look at your graphs here. So actually, I was just randomly searching for quick pictures and stuff for compound interest. But look at the difference in saving from when you're 25 versus when you're 35 versus when you're 40. You'd have to actually double what you're putting away in order to reach, and you can see you can never beat the 25-year-old line. So the earlier you start saving, the better it is for you. Okay, awesome. I see this another. Cecilia, yes, this is grade 11 revision. Cool. So here we need to get P by itself. So of course we divide by that whole bracket with the root of the power. So we can do it quickly on our calculator as well. Let me just, before I share this, make sure I know 13% 5 years, 1,000 Rand. Okay, cool. So on the calculator, we have 1,000 Rand is what we want at the end. 1 plus, we have 13% interest rates. So over 100, and then it's to the power of 5. Okay, and equals, and so she needs to invest 542 Rand and 76 cents in order to get 1,000 Rand in 5 years at a 13% interest rate. So you can see it's quite a you basically almost doubled your money in 5 years. So the more you save, again, the more you save. That sounds terrible, but that is really the truth there. Okay, so let's look at the inflation rate. So inflation rate is essentially compound interest, okay? And so to calculate your inflation rate, you take your new price, which is normally more expensive, except this year with COVID and crazy stuff that's going on. So I've used last year's data because otherwise it would actually be a negative interest rate. And then of course, you subtract the old price and you divide by the old price. So this is basically percentage increase, okay? Same formula. But we use it to calculate the interest rate as well. And then, of course, multiply by 100 to get to your answer. So I've used the December's fuel price versus the January fuel price. You can see it's quite a sizable difference. Okay. Oh, dear. Oh, you see, I was going to do it on the calculator. So let's see what this answer is. Right. I just want to move this so I can actually see my calculation. Right. So we have 1588 was the December fuel price, minus 1379 was the January fuel price, and we divide by the January fuel price to get the percentage increase. And then to get an actual percent, we just times by 100. And our answer is going to be, just change it there, 15.16%. Okay, so that's a very high interest rate and unusually high. So when we look at a normal interest rate, we normally look at something like 5 or 6%. That is the standard CPI rate for when you're looking at groceries, etc., etc. Normally, although look, 2020 is a crazy year, so we can't really take 2020's data. But if you look at previous years, 2019, 2018, all of our interest rates have been between 4.5% to 6% increase in pricing across the board. So what they'll do is they'll take a basket, which is they'll put bread, milk, your staples, the stuff that everybody buys all the time. And then they'll take the price of that in January and they'll compare it to the price of the next one the following year. So you can work out your inflation rate on a monthly basis or over a yearly basis or over a 5-year basis, depending on what the question is asking you. As long as you take your new price, subtract your old price and divide by your old price. Now you can use follow-up questions on this. So for example, they can ask you, okay, so if the inflation rate is 5, whatever percent, then what you're actually going to do is use it in a compound interest formula. Okay, cool. I see there's another question here. So Sekle, yes, we're only going to be doing finance today. The other stuff, probability and statistics, is on Tuesday and Thursday evening. Cool. All right. So population growth, again, this is a compound interest thing. And it's really interesting if you're looking at going into biology. I mean, if you're looking at the whole COVID situation, this is exactly an example of compound growth. So here's an example. It says a certain type of bacteria grows at different rates depending on what it is grown on. So the different agar plates and what it is fed, obviously. Each plate starts off with approximately 34 bacterial cells. So question A says, after 5 years, the first plate has 81 bacterial cells. At what rate did the bacteria grow? So in the information that we do have is that we ended with 81, so that is our final amount. We started with 34. We don't know what rate it is. That's what the question is asking us. And our N now is not measured in years. It's measured in hours. So you need to pay attention to the unit of measurement that you're using your time in. Okay. So we're just going to substitute everything in here. So it's 81 is equal to 34, 1 plus I over 100 to the power of 5. So now we need to get I by itself. So we're going to divide both sides by the thing outside of the brackets because that's on its own, inverted commas. And so we have a ratio over here, which is a good sign because we're looking for a rate. Take the root of 5 on both sides. So here you can see the 5 has disappeared. And then of course you have to subtract 1 from both sides. So now we have I over 100, and then I've just multiplied it by 100 so that I can get a final interest or final rate. And then of course we just type this all into the calculator. So let me just do it now so you can see it. So we have 100, open brackets. Now to get something with root 5, we first press the root and then we say second function and my exponent button. You'll see in orange above it, it says x root. Okay, so it's just saying whatever root you would like. And then we're going to say 81 over 34. And then we get out of the fraction. And then again, you need to press right again to get out of the root. And then say -1. If you don't get out of the root, it's going to change your answer completely. So just be aware of that, okay? And of course, our rate is 18,96, so almost 19% growth rate per hour. So that's a huge amount of growth, and that's particularly common in bacterial cells as well. I see there's another question. So yes, if you're in grade 12, you could use log laws, but you would use log laws to find the number of hours or the n value. So you don't use log for I, you only use log for when you're looking for your years or your period. Okay. Cool. So the second plate, this is actually an agar plate with various clusters of bacteria growing on it. I just thought something cool that you can see. If you start off doing a BSc and you do biology, this is one of the things that you'll do in first or second year, if I'm not mistaken. You'll grow bacteria like crazy. But it's really cool to see all the different kinds of bacteria that you can grow. Okay, so the second plate of bacterial cells is expected to grow at a rate of 22%. Determine how many bacterial cells are on the plate after 4 hours. So they're asking us how many at the end. We have 34 at the beginning, our rate is 22%, and it is 4 hours. So again, our formula is the compound interest formula, and we just substitute it in. And again, it's just a matter of typing it into the calculator. So there's all of your steps. I'm not going to do this one because I'm sure you know by now what steps to take. So at the end, they have 75 bacterial cells. Now remember, if you're talking about living things, you cannot have comma 3 of a bacterial cell. So you must round it off to a whole number. So it would be 75 or 76 bacterial cells, depending on your decimal place. So here we would round it off to 75 bacterial cells. Okay. Now, if we look at decay, decay is exactly the same as your simple and compound interest, except it is negative instead of positive. So with simple interest, it's called a straight line. And if you think about simple interest, that's exactly what it is. It's a straight line decreasing. So where your straight line, positive straight line goes from left up to right, your negative straight line will go at the top right to the, from the top left to the bottom right. Okay, and then of course compound interest is a reducing balance, and you'll see compound interest decaying can be very expensive for you. Okay, so Joe buys a car for 153,000 Rand. I don't think it's this one. If the car depreciates at a rate of 12% per annum for 4 years, how much is Joe's car worth using the straight line method and the reducing line method, the reducing balance method? So when we see straight line method, we need to read negative simple interest. Okay, so that we're going to use the formula where instead of a positive, we have a negative. Okay, and so what do we have? We need to know how much Joe's car will be worth after 4 years. So that is our A. We know that he bought it for 153,000 Rand. It is 12% and over 4 years. So we just substitute those values into the calculator. And again, it's just a matter of step-by-step typing it in. And so Joe's car on the simple reducing balance rate will be worth 79,560 Rand. Okay. Now, with the reducing balance, we're going to read negative compound interest. So our formula is exactly the same, except it has a minus instead of a plus. So again, all the same things that we had before, except our formula is now different. So we've got a 4 at the top instead of times 4. And again, you can just type it into your calculator. So here, his reducing balance is 91, or the value of his car is 91,000 Rand. So you can see it's quite a sizable difference between the simple and compound interest, or the simple decay versus the reducing balance method. Now, from here, we can have different periods of compound growth. So we can compound annually, which is every year, which is what we do in grade 10. When we start compounding on a monthly or weekly or daily basis, or even constantly, so we use the value of E, which many you won't really see in questions. So that's just a heads up. This is grade 11 work now. Okay, so what you do is you need to remember to multiply your number of years by your compounding period and to divide your interest by your compounding intervals. Okay, so if my number of years is 5 and my interest is 12 and I'm compounding on a monthly basis, it's going to be years times 12, which would be 5 times 12 is 60. And then my interest will be 20% divided by 12, will give me 1, whatever percent per month. Okay, so that's just, you need to remember to always do that when you're doing compounding intervals. Okay, so what I want to do now is just play around a little bit on the calculator with you and just show you what happens when you have different compounding intervals. So we're going to mode 2. The first one I'm going to do is just a basic compound interest graph with you. So I'm just using the same example I used earlier because, you know, I'm a creature of habits. And then we're going to put in an X. All right. So that's just a basic compounding yearly interest. Okay. What I'm going to do with the second one is do exactly the same thing, but I'm going to compound it on a monthly basis. So here I'm just going to say times 12 at the bottom, which means I'm dividing 10 by 12. And at the top, I'm going to make my X times 12. Okay, so that's there. And then we can say equals, leave our starting step at 0 and 1. Okay, so after 1 year, do you see, because you've compounded it monthly, you've actually gained an extra 4 Rand. After 2 years, you've gained an extra 20 Rand, an extra 10. After 3 years, you've gained an extra 20, and so on and so forth. So compounding your interest on a monthly basis is a much better investment than compounding on an annual basis, okay? And this is why it's so critical not to take out credit with the stores, okay? Because now you're really gonna feel it. Okay, so what happens, say for example, is if I compound it on a daily basis. So here I'm just gonna put that as 365 days, and I need to divide by 365 days and equals, again, start and step. So here you can see daily compounded values after a year is 1,105 Rand. And again, it just gives you a little bit more interest. So the more compounding intervals that you have, the better it is. And you'll see as you reach higher values, or the longer you do it for, the better your money will grow. Okay, so that's why if you can get something with compounded daily or compounded monthly versus compounded yearly, it's a much better way to go. But then also remember that the banks use this in their favor. So if you're buying a car, they're also going to compound your interest monthly. So just be aware of that as well when you do your calculations. Okay. So the last thing that I want to go through with you today is nominal and effective interest rates. So I took this from Kevin Smith's Handbook and Study Guide. He does quite a nice explanation there, and this formula is particularly from there. So your nominal interest rate is what the bank advertises to you, okay, or the car salesperson tells you, hey, don't worry, it's only 12%, but it is 12% compounded monthly. So then we need to know what we're actually paying in interest over 1 year. Okay, so your effective interest rate is your interest rate that you're actually earning over 1 year, whereas your nominal rate is the rate that you're getting per units that you are compounding. So the months or the years, or the days, whatever you're using, and then it's to the power of your U. Okay, so determine the effective interest rate if the interest rate offered is 12% compounded weekly. Okay, so we need our effective interest rate, that's 1 plus IF. Our nominal interest rate, that's what was advertised to us, is 12%, and it's being compounded weekly, and there are 52 weeks in a year. Okay, so here we just substitute in our values, we subtract 1 to get the interest rate by itself, and then of course we type it into the calculator and we get 0,12, and if we multiply this by 100 it gives us 12,73%. So our effective interest rate is almost a percentage higher than the advertised interest rate. Okay, awesome. So that is the end of that. It went much faster than I thought it would. So before we end off, I just want to tell you about the Future Fund. This series of workshops that we are doing is in aid of our Future Fund 2.0. What we are trying to do is raise money to give students who cannot afford their own calculators. So for every donation you make of a calculator, Sharp and S&D Technologies will match your donation for that calculator. Okay. So I will send you a Zapper donation link. I will actually do it this time on Monday when I send a link to the recording as well as the notes. Cool. Thank you very much for joining me on Saturday morning. If you need worksheets on financial maths, as far as I know, all of the content for grade 10 to 12 financial maths is developed. So just send me a mail and say, hey, Tel, please send me grade 10 maths, financial maths, and I'll send you the worksheets and the memos for that as well. Okay. Are there any questions before I end off today? Cecilia, yes, we are all done now. You can run away and have a nice Saturday. But if you do need worksheets, remember that you don't tell the teachers I told you if you're a student. Teachers, block your ears. But you can register as a maths teacher on the site and just download the worksheets yourself. If you're struggling. So I normally only look at emails between Monday and Friday. So yes, and then if you do have questions, you're welcome to send them on the Maths at Sharp student question page. I try to get back to you within 24 hours. So don't send me a homework question that needs doing for the next day, because that's not going to help. But if you're studying for a test or you need help with that, then let me know. And I'll definitely try my best to help you in the best way that I know how. Awesome. Any questions, anything like that? It's a pleasure, Michael. Cecilia, yes. So email me and I will send you a worksheet. Okay, let me just put my email address here in case you didn't get an email from me. Technologies.com. There you go. So my email address, and here is the link to Maths at Sharp. Okay, so those are the two really great websites. You can get hold of me through either of them. And then if you like the calculator, they are at all good retailers. Okay, cool, awesome. Any other questions? Are we all happy? Great.